Hello and welcome to the second topic in this chapter on gameplay attributes. We now move on to the first planet in the gas solar system of our actor. So in most video games, attributes are stat points, which can be as simple as float values. But by game design, what are attribute sets? It could be a way to compartmentalize attributes and handle the interaction between many different attributes. For example, in Dota, strength may increase health regen, agility will increase movement speed, and maybe in Elden Ring and Dark Souls, dexterity could improve weapon damage. So in this topic, we'll be learning how to create attributes and attribute sets and grant them to the ASC actor. In the first section, we'll be creating and granting attribute sets. So in the Unreal Engine editor, in the C++ classes directories, project folder and public folder, I have created an ability system folder within which I have the attributes folder and within which I've got 3 attribute set classes: the base attribute set, battle attribute set, and core attribute set. So I want you to create this base attribute set C++ class. Go over to the tools menu and click on new C++ class option. In the all classes section, search for attribute set. You will notice I already have my base attribute set class subclass from this attribute set class. So select attribute set and click on next. Provide a name for your attribute set. You may want to keep the name of your attribute set in capitals just to identify it better. And in the path, create the folders ability system and attributes. Make sure to select the public class type so that in the public folder you'll have your header file, and in the private folder you'll have your C++ file, and then click on create class. Now your base attribute set class will be created in C++ and your code will be compiled. So open up your project in your preferred IDE, and this is what your base attribute set class will look like. This is where we will be defining our base attributes. So let me first specify the different attributes I need in this base attribute set in a multi-line comment. This is where I wish to declare my health, stamina, and mana attributes. I have health, and I also wish to declare its max health, which can be modified at a later time. And after the health and max health, the health regen. So these shall be my health attributes, and I shall make the same attributes for mana. So now I have mana, max mana, and mana regen. And similarly, I have the stamina, max stamina, and stamina regen. So for now, these are the 9 attributes I wish to declare in this attribute set. So in my base attribute set class, I'll create a properties section, and under the public access specifier, I shall start declaring my health attributes. So any gameplay attribute in GAS is of the type gameplay attribute data structure, and I shall name this property health. You may right click on the F gameplay attribute data and click on go to definition, and this will take you to the attribute set header file, where you can see that the gameplay attribute data is indeed a structure, and this structure actually has 2 values, the base value and the current value, but more on that later. I shall also specify the uProperty macro and make this health property read only in the blueprints in the category base attribute set and health. So now the value of this health attribute can be read in the blueprints. So this is how you declare any attribute in an attribute set. And they're not float values, they're actually of the type struct f gameplay attribute data. Similarly, I shall declare my max health and make that read only in the blueprints under the same category base attribute set and health. And then I shall declare my health regen attribute, which is again blueprint read only in the same base attribute set health category. So these are my health attributes in the base attribute set. Likewise, I shall create my mana attributes, that is the mana, max mana, and mana regen in the category base attribute set and mana. And similarly, I shall create the attributes for stamina. So it is mentioned in the GASdocumentation's README file that attributes are float values but are defined by the struct f gameplay attribute data. So attributes are defined by and live in an attribute set. And these attributes should also be replicated in a multiplayer environment. So as I had stated, an attribute is composed of 2 values, a base value and a current value. So the base value is indeed the actual value of the attribute, whereas the current value is actually the base value and some temporary modifications that come from gameplay effects. So for example, if your character gets a temporary increase in movement speed, the base value will remain the actual value, but the current value will have a temporary modification, and whenever the temporary effect expires, the current value will revert back to the base value. So you don't really need to take care of snapshotting values or resetting values whenever temporary effects end, and changes in the attribute values. So now it's time to grant this attribute set. This can be done at the time of granting the ability system component itself. So open up your base character header file. First, I shall forward declare the base attribute set class, and then in the bottom of this header file, I shall create a section for attribute sets, and under its properties subsection, I will declare an object pointer to an attribute set. So technically, these attribute sets are instantiated for our ASC actors, kind of like components. I shall just mark this as a U property, just to give it additional functionalities, and I will move on to the method subsection, where I will create its getter method that returns the base attribute set object pointer, and in its definition, I shall simply return the base attribute set variable. So open up the minion C++ file, and this is where we'll be granting the base attribute set, soon after granting the ability system component. So I shall first declare the header file, and it's a great idea to include header files in the C++ classes, and forward declare these classes in its relevant header file. This can help prevent circular dependencies. And now in the minions constructor, I shall grant the attribute set, again using the createDefaultSubObject method. For the template parameter, I shall pass a base attribute set class name, and for the name of the subobject, I shall just pass a text, base attribute set. I shall reference this object pointer using the base attribute set property that I had declared in the base character class. So yes, this is all there is to it to grant an attribute set. You just have to grant it using the createDefaultSubObject method. So after granting the attribute set for the minion, it's now time to grant this attribute set for the player. So open up the base player state header file in the src game folder, and in this class we should be doing the same set of operations that we did for the base character and the minion. I will forward declare the base attribute set class, create a new attribute set section, have the object pointers to the base attribute set, and create its getter method. Now open your base player states C++ file, and similarly in here we'll be using the createDefaultSubObject method and granting the base attribute set and referencing it with our base attribute set variable. So now you may build and compile your code in the build task editor development build, and this will start generating the build files for your game. And now you may launch your editor. I like to launch my editor in the debug mode, so I will go to the run menu and choose the start debugging option. So now the Unreal Editor has opened. You can see that the level looks a little different now. I just simply removed the walls along the 4 sides and increased the size of this plane. Also in my base folder and in the pawn folder, beyond the hero class, I now have my blueprint minion class. The blueprint hero also looks different. I have just changed the material to burnished steel, which is part of the starter content materials. And for this blueprint minion actor, it is just the same Unreal Engine 4 mannequin, but it has a scale of 0.7. And now it's time to play the level. So yeah, this is my blueprint hero class, and this is the minion. And now if I execute the console command show debug ability system, in the debug information, there are the attributes from the base attribute set class. In the previous topic, this was quite empty, that is, we didn't really have any attributes, but now you can see all of the attributes that were granted from that attribute set class. In this Epic Games documentation, the link of which has been provided in the description down below, you can see that in the giving the attribute set, you can grant attribute sets using the createDefaultSubObject method, and you can also grant them in a dynamic way. There are 3 methods for this: the get or create attribute subobject, the template method addSet, which will internally call the get or create attribute set subobject method, and the add attribute set subobject. So this can be really helpful if you want to grant attributes and attribute sets dynamically during runtime. In the second section, we will be implementing meta attributes and attribute accessors. In order to damage or heal the health of this ASC actor, I will have to subtract from or add a float value to the health. And as per my game design, damage subtracts from health and healing adds to health. For this purpose, I will create another attribute called health meta, and likewise the mana and the stamina metas. Now I can only override these meta attributes and they will operate on the health. So let me go ahead and create this health meta attribute. So this gameplay attribute will be in the category base attribute set, health and meta. Similarly, I should create the same meta attribute for mana and finally for stamina. So this is a cleaner way to deal with attribute value changes. This has also been mentioned in the GASDocumentation project, where some attributes can just be temporary values, and they will just simply interact with other attributes. So for a meta attribute damage, you can now refine this damage value with buffs and debuffs, damage amplification, or damage negation with a shield, before actually subtracting that value from health. So this can prevent directly operating on health, mana, or stamina attribute values. Now after having declared these meta attributes, we shall implement something known as Attribute Accessors. So right click on the attribute set class name and click on Go to Definition. Visual Studio Code took me to the header file of the attribute set class, and scroll all the way down to the bottom. You will notice that in the complete bottom there's a really big multi-line comment under which there are definitions for a few macros. So basically, we need some helper functions to access and modify these attribute values, and this is done using these macros. I have provided a link in the description and you can read more about macros in C++, but for now, just understand that macros are quite like functions. They are defined like this using the hash define keyword and then the macro name, and they have parameters just like a function. So this macro here takes in the name of the attribute set class, and also takes in the name of the attribute property and returns the fGameplay attribute struct. Similarly, this macro generates a function that will serve as a getter function for the specified attribute. It will simply return the float value of that attribute's current value. And similarly, you have a setter function for a particular attribute property and an initter that initializes an attribute property by taking in a float value and setting its base and current values. So if you want to know more about how this works internally, you can check out the link I've provided on the Unreal Engine's reflection system. So the Unreal Engine's reflection system can identify named properties in your source code and use that to work on certain operations. Like in this case, creating the relevant getter and setter methods for our attribute property names. We're only interested in this block of code, the macros that generate the helper functions for our attributes. 2 getter methods, 1 setter method, 1 initter method that is used for initializing the attribute values. Note that this getter method on top is just to get the attribute property, whereas the others deal with the attribute's values. So just copy these lines of code, and in your base attribute set class, those lines under your header files and above the class definition. Yes, you will have to delete those accessors if you may have copied them. This completes the first part of using the attribute accessors. The second part involves using this attribute accessors macro. This accessor is called after the declaration of this attribute property. It requires 2 parameters, the class name and the property name. So for the health attribute, use the health property name. So the attribute accessors macro is called the parameter base attribute set class name, health attribute name. Now I shall do the same for the other health attributes, and also for the mana attributes, and finally for the stamina attributes. So let me show you the importance of these helper functions. In my base character class getter function for the base attribute set, let me just write a small line of code here. You can see that IntelliSense is able to get my base attribute set variable, but when I attempt its properties, when I type health, you can see that I don't really have any getter and setter methods for my properties. I have publicly exposed my health property for any class to access. This is not a good way to protect, secure, and encapsulate your properties. This can be accessed and modified by any class. So I shall declare them under the protected access specifier. So you may now save this base attribute set header file to reverse the changes in the base character header file. And these attribute macros require the ability system component header file. Now go ahead and compile your code. So now my code has been successfully compiled by build. So let me try that again in my base character header file. Actually see the getter, setter, and initer methods certain attributes. You can also see the red squiggle under the health property. States that the health is inaccessible in this class. This is what happened when we use the protected access prior for the declarations of these properties. You can also the setter method for stamina and initer method for mana. So attribute accessors are really simple. You just need to copy paste this line of code from the attribute set class and call the attribute accessors method after each attribute property declaration. In the third step, we will be implementing a method, the Preattribute change. So go over to the attribute set class and you will notice that this class defines several methods, such as pre-gameplay effect execute, post-gameplay effect execute, pre-attribute change, and post-attribute change. We are interested in this method, the pre-attribute change. This method is called just before any modification happens to an attribute. So just before the attribute value changes, this is the method that will be executed. So you can see that this method does not provide much information because this can be invoked even beyond effects, like a simple setter method from the Attribute Accessors helper function. So the developers have suggested that this would be a great place to clamp your health between 0 and the maximum health. So GAS does not know your game design. It does not know that health cannot go to the negatives or that health should not exceed the maximum health. So as developers, we should write the rules as to how our attributes interact with each other. And that is what we will be doing in this pre-attribute change method. So copy that method declaration. In the base attribute set class, I will create a new method section, and under a public access specifier, I will first declare the constructor of this class, below which I will paste that method declaration. Since we are overriding this method from the parent class, I will specify the override keyword. In the base attribute sets constructor, I shall initialize certain attributes. I will call the initer method of the max health attribute. This method takes in a float value and I shall hardcode a value of 300. So basically I'm initializing the max health to 300. Similarly, I shall initialize the maximum mana to 300 and the maximum stamina to 300. Now in the definition of the pre-attribute change method, I shall clamp my health value between 0 and the maximum value. First, I shall call the superclasses method, and then, using an if statement, I shall validate if the incoming attribute is health. Notice that the incoming parameter is of the type fGameplay attribute and the new value of this attribute. So it's from this attribute parameter that we can identify if it's a health attribute. I shall validate to see if we are actually dealing with our health attribute. If attribute equals our health attribute obtained using the getter attribute accessor method, then we have to modify the health's new value, since this new value will be the new attribute value. So I shall assign a new value which will be clamped using the fmaths clamp method. This method requires 3 parameters. Firstly, the value to be clamped, secondly, the minimum value, and thirdly, the maximum value, for which I shall use a getMaxHealth attribute accessor method, which actually returns a float value. So in this manner, I have clamped the new incoming value for health between 0 and the maximum health. And now this new value will be used as the new attribute value for my health attribute. And I'm validating if it is indeed my health attribute that I'm operating on. Similarly, I shall validate for my mana attribute and set its new value clamped between 0 and the maximum mana. And finally for my stamina attribute, where the new value will be clamped between 0 and the max stamina. So notice how I'm using the getter attribute accessor methods, where one returns the attribute and the other returns the float value of the attribute's current value. And now it's time for replication. Generally, in Unreal Engine C++, in order to replicate any property, we use the getLifetimeReplicated_props method. This method is not a part of the gameplay ability system. In the definition of the getLifetimeReplicated_props method, which takes in a parameter of an array of structs fLifetime property, I will first call the superclasses method, and then I will call the method doRepLifetime condition notify. So this macro is used to replicate a class's property by specifying its rep notify conditions. So the first parameter it requires is a class name, which will be the U-base attribute set. The second parameter is a variable property. And since I wish to replicate my health attribute, I shall pass health for the second parameter. The third parameter is the rep notify condition, and for that, I shall specify condition none. And finally, I shall specify rep notify always. So this line that I just wrote is the equivalent to making a blueprint class variable lifetime replicated. But this does not just end here. We will have to define certain methods using which our attributes will replicate. So I will create a subsection called methods for replication, and under which I will declare a method called onReplicatedHealth, which takes in a single argument, the old health value, which is of the type fGameplayAttributeData structure. I shall declare this method as a uFunction using the uFunction macro, and this uFunction macro is required by a certain method in this function's definition. So yes, this is part of the GAS boilerplate, and you will need this method for every attribute that replicates. So in the onReplicatedHealth definition, I will call the method GameplayAttributeRepNotify. This macro is required for various operations in GAS, such as prediction and others, and it requires 3 parameters. The first being the class name, which will be the U-base attribute set. The second would be my health attribute, and the third parameter is actually the old health value, and this is nothing but that incoming old health attribute data. So I shall pass that incoming parameter into the third parameter of this GameplayAttributeRepNotify macro. So yes, this macro will take care of many networking needs like prediction, replicating efficiently, and so much more by the gameplay ability system. And finally, we need to specify that replicating method in this health attributes declaration. So in the uProperty macro, you will need to pass a third argument, that is for its replicated using argument. So you need to pass the replicating method into this replicated using argument. And for my health attribute, it would be onRepHealth, which has been defined down below. So yes, this is how you replicate any attribute. You specify the attribute in the getLifetimeReplicated_props method, and you implement a replicating method, which will be used in the uProperty macro for every replicating attribute. You may just pass repNotifyAlways and none condition for this property in its doRepLifetimeNotify method. You just have to call this macro GamepAttributeRepNotify in its replicating method. Oh, and I almost forgot. You should include this net Unreal Network header file. And in the similar manner, I will do the replication of the other health attributes. So I will declare the replicating methods for the max health attribute and for the health region attribute. So in the max health and the health region declarations, I will specify the replicating methods in the replicated using uProperty argument. Now in the C++ file, I will first specify the max health attribute to be lifetime replicated, and similarly for the health region attribute, and create the definitions for the replicating methods of the max health and the health region. And so for the health attributes, we will stop right here. We will not be replicating our health meta. The meta attributes need not be replicated. This is because in our attribute set class, the pre-gameplay effect, post-gameplay effect, pre-attribute change, post-attribute change, and others actually execute on the server. And it is in these methods that we intend to modify the health value based on that health meta. So it's better to allow the server to modify the health attribute that will in turn get replicated to every client. So I shall not be replicating this health meta now, and I shall replicate my mana attributes. I shall specify the replicating methods and copy these lines to declare those methods. And after my health attributes, I shall now specify my mana attributes for lifetime replication. And finally in the replicating methods, and finally define my replicating methods for each of these mana attributes. Again, I'm not replicating the mana meta. Similarly, for my stamina attributes, I shall specify the replicating methods, declare the replicating methods, make the stamina properties lifetime replicated, and finally define those replicating methods, where I will use the GameplayAttributeRepNotify macro. So yes, this is all there is for replication. This is part of the GAS boilerplate, so it's just repetitive code that you can keep copy-pasting and just replacing some property names. But this has to be done for replicating any attribute. I will summarize these steps in the end of this topic. fifth section will be an assignment for you. I want you to create the battle attribute set and the core attribute set. I want you to apply what you've learned so far, or create these attribute sets with their relevant attributes and grant them to the base character. So I want you to create these attributes in the core attribute set: strength, agility, and intelligence, and their corresponding attributes. Similarly, the battle attribute set, I want you to create these attributes: armor, magic resist, movement speed, attack speed, cooldown reduction, and the spell amplification. I want you to create the relevant max attribute and the meta attribute. The armor is a percentage between 0 and 100, and so is the magic resist. I want you to do the relevant clamping. For the movement speed, I suppose you can just ignore it for now. The attack speed is also a percentage between 0 and 500. The cooldown reduction is a percentage that does not reduce below 20. And finally, the spell amplification, which is also a percentage factor, which cannot go below 0. So implement their clamping methods, the attribute change. Make sure to duplicate all attributes except the meta attributes. Initialize your attribute value. So I think such assignments are great for practical learning. You will usually implement something and see the results. So I like this kind of pragmatic learning, where when you see those results, you will know that you can apply what you have learned. And this is the best way to learn programming and game development. And so this brings me to the end of this topic on gameplay attributes. It's not really that difficult, but I had to cover so many things. And it does include a lot of boilerplate code, which is why I offered the assignment. Because you will learn the various elements of this boilerplate code. You will learn what is needed and when it's needed. I will now summarize what we learned in this topic. In the first section, we created attributes and granted attribute sets. We created the base attribute set class, created the health, mana, and stamina attributes, and learned that attributes are actually of the type fGameplay attribute data structure. And these structures actually hold the base value and the current value of an attribute. We learned what is the base value and the current value. That base value is actually a permanent value of the attribute, whereas the current value is a base value plus some temporary modifications from certain gameplay effects. For example, a temporary gain in movement speed or health will mean only the change in the current value, and after the expiration of that effect, the current value will revert back to the base value. And so, having declared these attributes, we granted this attribute after granting the ability system component in the player states constructor and in the minions constructor. In the second section, we learned about meta attributes and attribute accessors. We learned how we can create a meta attribute such as health meta, and these meta attributes can be temporary values to interact with other attributes. So these meta attributes provide a great logical separation between damage and healing and health. So now a negative health meta could mean damage and a positive health meta can mean healing. So this is a much cleaner way to deal with attribute value changes, rather than directly operating on health, mana, or stamina attribute values. We still haven't configured how our health meta can subtract or add from health, and this will be covered in the next topic on gameplay effects. In this section, we also implemented attribute accessors, where it involved defining these attribute accessors macros and calling these macros after the declaration of our attribute properties. So this helped expose certain helper functions for these attributes, such as the relevant getter, setter, and initer methods, thanks to the Unreal Engine reflection system. In the third section, we implemented the pre-attribute change method, where we validated if the incoming attribute was our health, mana, or stamina attributes, and accordingly clamped the new value between the 0 and the max health. This method is called just before any attribute change, so this new value argument is what will be the new attribute value. In the fourth section, we replicated these attribute properties. We had to replicate using a replicating method, and we had to specify that these attributes are lifetime replicated in the getLifetimeReplicated props method. So we replicated all attributes except for the meta attributes. The meta attributes are operated inside these attribute sets methods, such as the pre-gameplay effect execute, post-gameplay effect execute, pre-attribute change, and post-attribute change. Since these methods are called on the server, we can just allow the server to modify that health value based on that health meta attribute value. And after specifying the lifetime replicated variables in the replicating methods, you must call the gameplay attribute rep notify method. This macro is part of GAS, and GAS needs this for various operations like efficient replication, prediction, and so much more. Oh, and don't forget to include the net Unreal Network header file. And the fifth step is your assignment, and I guess I can just skim through the solution. So in the core attribute set class, the requirement was to create strength, agility, and intelligence attributes with their relevant maximums and metas. So it follows the same steps that we have learned in this topic, each attribute being of the type gameplay attribute data, replicating using a replicating method, having their attribute accessors helper functions, for which their macros were defined in the very beginning of this core attribute set class. And optionally you can implement a constructor and initialize the values of certain attributes. In the pre-attribute change method, we clamp the new values of strength, agility, and intelligence between 0 and their relevant maximum attribute values. You can obviously validate for these attributes using the incoming attribute parameter and the relevant getter method for the attribute. In the getLifetimeReplicated method, I specified the lifetime replication properties of all but meta attributes. And finally, in the replicating methods, I call the gameplay attribute rep notify macro. This is the same implementation for the battle attribute set, and in the C++ class, in the battle attribute set constructor, I've initialized different values for different attributes. Make sure to understand what would be the default values in your game design. In the pre-attribute change, for the max armor of 100, if the attribute is the armor attribute, the armor value is between 0 and 100. Similarly, the magic resist is between 0 and 100, having set the max magic resist to 100. Now this character movement speed will be done differently in chapter 4, so you may completely ignore this. So the attack speed is also done the same way. All of these are done using an if-else-if ladder, and the cooldown reduction shall not decrease below 20%. So if the attribute is actually the cooldown reduction attribute, and its new value is less than or equal to 20, the new value will be set to its current cooldown reduction value. So this can prevent the cooldown reduction attribute value from ever going below 20. And finally, the else will be used to operate on the spell amplification, where if the new value is less than or equal to 0, then the new value will be set to the current spell amplification value. Notice that both these operations, on cooldown reduction and spell amplification, did not use clamping but simple if statements. And rest, everything else is the same, except for replication of the meta attributes. So yes, this topic may have felt very verbose, you may have felt like I explained a lot of theory, but this knowledge can help you with the know-hows of attributes and attribute sets. I hope this video can help you implement this into one of your projects. If you have any queries, leave them down in the comments below. So thank you and see you in the next one.